All right, welcome back, everybody. Happy New Year. Hopefully, you guys are able to enjoy the holidays with your families. Now it's time to get started with adding gizmos to our editor. The gizmos will be separate to the tile tools that we created previously. However, they will have some similar functionality. So, what are gizmos anyway? Gizmos are visual elements that will allow us to manipulate game objects or entities in our editor. In our case, gizmos will allow us to make adjustments to transform properties of a selected entity. These are basically convenience widgets that will allow us to quickly change the position, scale, and rotation of our game objects. We can already achieve this right now by changing the object properties in the properties panel. However, with the gizmos, you can make the changes faster and then use the properties display to tweak the values if needed. All right, so the gizmos that we're going to create are the translate, scale, and rotate gizmos. As you can see here, there are some textures that I've created for this. These are just simple textures that I added using Sprite, and then I converted the PNG binary to an unsigned char array and added these as editor textures. I've already done this. I've already added these to the GitHub repo. Make sure you grab these from the latest commit to easily follow along with the next few videos. All right, so what are our gizmos going to need? We're going to need to have sprites for each of the X and Y axes of the gizmo. The rotate gizmo will only need one axis because we're only doing 2D rotations. We'll need to have transforms for each axis. This will allow us to draw the axis and do some scaling and offsets that may need to be applied. Lastly, the gizmos are going to have different colors for the axes. The colors are used to notify the user if the gizmo is hovered or disabled or just there in general. As you can see here with the translate, we have a green and a red for the X and Y. And when you hover over it, it changes color, okay? You can't see that here, but it will when we actually get to programming it. All right, lastly, let's take a look at the gizmo's architecture. The gizmo class will inherit from the abstract tool that we created previously. A gizmo is just another tool that we'll need to use, and it will need to have the same functionalities, such as the mouse coordinates, tool activation, bounce checks, etc. These are already handled inside of the abstract tool, so we can just reuse and repurpose this. The gizmo class will also be a parent abstract class for the concrete gizmos, similar to the way that we handled the tile tools. We won't want to be able to create the gizmo itself, rather we'll use it for polymorphism. As you can see here, we'll have the class translate gizmo, the scale gizmo, and the rotate gizmo. These are all going to inherit from gizmo, which will also have some pure virtual functions inside of this, so we can't actually create the abstract class. And finally, we'll have a simple struct that will hold all the gizmo axis parameters. This will hold all the common attributes necessary for each axis. All right, so now that we're done with a quick overview of the goals for the gizmos, in this video, we're going to create the gizmo parent class, and let's get started. All right, so as you can see here, I'm just showing the textures that I made for the gizmos. Just this X-axis arrow, and this axis scale, and the rotate. These were all made inside of Sprite, and then we just added them to the application here from memory, and we're using it, setting it as a editor texture. Okay, we can actually close these. Make sure you grab this, by the way, if you want to follow along directly. We're not going to need them necessarily in this video, but we will need them when we actually start making the concrete classes. All right. Okay, so the first thing we're going to want to do is actually go into our editor utilities, and right here, so editor utilities, and this is where we're going to put our gizmo axis params. And we'll do that. We can do that right here. So kind of like how we did the tile struct here. Well, we're going to want to kind of something similar for the gizmo. So we'll say struct gizmo axis per. And this is going to need your transform component and sprite component. So we can actually just copy both of these right here. Paste that in. And we're going to need some color. So we're going to have, and we'll have an offset. So we'll say GLM vec2 axis offset, just in case the axis it needs an offset. Then we'll have the Scion rendering color, and we'll have the axis color, just a regular color. And this can actually default probably to white, but we'll leave it as is. I think it defaults to white in the color class anyway. We can just copy these down a couple more times, and we can have the axis hovered color and the axis disabled. Cool. And let's actually create a couple const expr values here for the color. So we can say, so we're going to go const expr Scion rendering color. We'll say x axis Gizmo color. And I will have the x-axis start as red. It's going to be 255, 0, 0, and slightly transparent. Then we'll do the x-axis hovered. And we'll make that yellow. Is that yellow? I think that's yellow. And we'll copy both of these. And change these to Y. And Y will default to green. And the hovered and then we're going to do our disabled, and that'll just be a gray color. Copy this down. Change this to grayed out. These will just be all 135. 5. Cool. So these will be our default colors. Now, these don't have to be used. Change them whatever color you want them to be. Now that we have that, we're going to actually create our Gizmo class. So let's go into our tools. Let's create a new folder. Add new folder. This will be our Gizmos. And inside of Gizmos, we will add a new file. That's going to be Gizmo.h. Yep, add it in. All right, so we can add our pragma once. Pragma once. Namespace. Scion editor. Cool. And as we said before, it's going to inherit from the abstract tool. So let's go include editor, tools, abstract tool. We're also going to need memory. Include memory. And we're going to need to include the entity because we need that for the selected entity. So let's create our Gizmo class. So class Gizmo going to inherit from the abstract tool. We can go Control KD. Right. So I'm actually going to put the public section here. We're going to have a protected. All right. Publicly, we're going to have a default constructor. And we're going to have another constructor, Gizmo, that will take a const Gizmo axis params reference x params. And we're going to do the same for y. And then we're also going to have a flag to set if it has one axis or not. One axis. Cool. And we're going to have to forward declare this up here. It's going to be a struct. Cool. And we're going to have to do a override. So virtual void update. This needs the canvas reference. This override. Now this is from the abstract tool here. So we can go struct canvas. Now if you want, I see this being common, you can just say something like begin abstract tool. and abstract tool. Anything that's abstract tool related can get put here. And then I also want to make a virtual void draw equals 0. The reason we're doing this is so that you can't actually create a gizmo by itself. You can only create the concrete classes, and that's what the goal for this is, making this pure virtual. You're going to have a void set selected entity. That's going to take in entity void. We want to be able to hide the gizmo, and we also want to be able to show gizmo. Then we can have another function. This can be inline bool. Are we over the gizmo? Const. Now I won't fill this one out yet because I haven't made the, so we'll just return false for now. We'll come back and do this in a minute. All right. That should be good for our public stuff. We can actually get rid of this. We know this is part of the abstract tool. Cool. So in our protected, we're going to have a initialize function. So void init, and that's going to take in our const std string reference, and that's going to be for the x axis texture. And we're going to want to do the same thing for the y-axis. This will do all the initialization and generation of UVs for the textures. We're going to need to override the examine mouse position. So virtual void examine mouse position. Override. Okay, when we're using the gizmos and we click on one and we start to pull in a direction, we're going to need to get the delta or the change in position from when we first pushed the mouse button and then when we moved it or translated the mouse button or the mouse position. We're going to need to get that delta back so we know how much to translate, scale, or rotate our objects. So we can just say float get delta x and get delta y. Cool. All right. And then we're going to have another function that will set the gizmo position. Okay. Void set gizmo position. We have an entity that's selected. We need to set the position of the gizmo to where that entity is, because it could be anywhere on our canvas, right? So we can go Scion or ECS entity reference selected entity. And we're going to have to forward declare this up here. So outside of the editor, we can go this. This is a namespace. Cool. All right. So we're also going to have some protected variables. And first is going to be an std unique pointer of a gizmo axis params mp x axis params. Same for y. And we also want to have another unique pointer for the batch renderer for drawing, because it's going to just be exactly like the tile tools. It's going to handle its own drawing. Okay. Copy that down. Scion rendering. Right. Is that what we called it? I believe that's what we take a look. And we could probably check this right from here. Oh, this one uses a rect batch tool. Okay, so we use a shared pointer here. These probably don't need to be shared. You can probably change those to unique. And yeah, sprite batch renderer. Let's just copy this. Sure. Take this. Might as well take that forward declare as well. Go back here. Paste this in. Come back to file tool. Copy this. Gizmo. Forward declare. All right. And then down here, we want to go ENTT entity M selected. And GLM vec2 M last. I'll say translate position. Not necessarily a translate position per se, but this is the, or we can say last mouse position. So when you first update, it checks the position of the mouse. That's what we need. And we're going to have a bunch of flags here. Bool MB over x-axis over y-axis. We want to have another one if we're not over it. So when you first click it and then you move around, you might not still be over the axis, but we still want it to hold. So we'll say holding x, MB holding x, holding y. Is it hidden? MB hidden. And MB only one axis. So we're going to use this flag to prevent us from trying to draw multiple axes if we don't have two. So if we only have one, we're going to default to using the X. If we have both, we'll use the Y as well. Okay. And this will make more sense when we actually make the rotate gizmo. All right. So now that we have that, we can make all these functions. But before I do that, I want to create the gizmo.cpp file. Add new file. Gizmo.cpp and apply. And we can include our gizmo.h. So namespace, Scion editor. All right, close these. Close that. This. And let's make all of these. It'll let us make. Create. Awesome. Looks like it created them all. Let's go over here. Beautiful. All right. So we'll skip this one for now and we'll do this one first because this one will just fill out this one with default values that we're going to give it. Okay. So the first thing I'm going to want to do here, my initialize of the list, is to do my abstract tool. And then I want to do the batch renderer, MP batch renderer. Oh, I didn't change the name of it. You guys probably caught that already. MP batch. Now we're not doing these ones first because we don't want to initialize these right away. I guess you could initialize them to null pointer if you like. Actually, that's what we will do. We'll initialize these to null pointer first. So MP x axis params null pointer y axis params. Cool. And now our batch render. Right there, we can just go std make unique. And it's going to want to be the Scion rendering batch server. Right batch render. Cool. Now, before we continue, we actually have to put some includes here. Go to the top. Let's add some includes. So let's add in our main registry. Include for yes, main registry. Include for resources asset manager. Include for ECS entity. Let's include our components for ECS components, all components. We're not going to need all components. It's just easier. Include for utilities. For utilities, we're going to need the editor utilities. Include editor utilities. Editor utilities. We're going to need the logger. Include logger. We're going to need the batch renderer. Include rendering. Or batch render. And we're going to need include rendering essentials. Oh, do we even need essentials for text? I'm gonna put it in anyway. And we might as well go using namespace space Scion core. Yes. Just so when we do the components, it's a bit cleaner. We don't have to do all of this. Rendering, we're only going to do this one time so that can stay. I forgot to add an angle bracket here. Cool. All right. So batch renderer, then we're going to have, let's take out the order that we put these in. The selected entity, the last mouse pause, and you know what? Let's just copy all of these over. Copy these over here and paste. Now, it's not the best way to do this, but I'm going to do it like this anyway. One at a time. ENTT null, start as. This one, last mouse position. That'll just be 0.f. Cool. Now it's fast and ugly, but it did the job. Now the one axis I don't want false. I just did that fast. I actually want to go B one axis. All right. So now in the constructor, we're always going to want the x-axis to be made. So we want to go M P x-axis params is equal to std make unique Gizmo axis params. And that's going to take in the x-axis params. Okay. Now here we want to go if MB only one axis. We're just going to return. We're not going to make the y-axis. That'll just stay null pointer. Okay. Otherwise, we'll copy this and change everything for y. Y-axis. Y-axis. Awesome. Okay, so for the Gizmo update, all I want to do here is update the abstract tool. So abstract tool update. That takes in the canvas. Now the draw shouldn't have been made because that is a pure function. So it shouldn't have made that. Okay, so to set the selected entity, all we're doing is setting the M selected entity to the passed in entity. Okay. So if the M selected entity is not equal to ENTT null, I'm going to want to set the position of the entity. But we also need to make sure that the registry is valid, and we get the registry from the abstract tool. Okay, so the abstract tool automatically gives us access to the current registry that we're running for the scene. Okay, and we'll say Scion for ECS. We don't have to do that, so we can say entity, and that's going to be the MP registry and the entity, because we have that constructor, and we can pass that into our set Gizmo position. Hopefully that makes sense. So what we're doing is we're just setting our entity to the entity passed in. If the entity that we're setting it to is not ENTT null and our registry is valid, we want to set the position. Cool. So let's do the hide function. So we can just go if MP x-axis params MP x-axis params right.be hidden is equal to true. Copy this, and we do the same for y. Now, why are we doing this check here? Because y might not be valid. because if we're only using one axis, this won't be created. Okay, so if we just do a quick check here, might as well check for both. And we can say MB hidden equals true. Cool. And we can copy all of this for show. It's basically the same thing. Paste it in, just change it all to false. 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 Awesome. But we also don't want to show one more thing here. We don't want to show if the entity is null. Let's just put all this into. So we go if, make sure it's hidden already, and M selected entity is not equal to ENTT. No. If there's no entity selected, I don't want to show these. No need to show the gizmo if there's no entity. All right, so now the initialization function, we just want to set up the x-axis. So set up x-axis. So the initialization, we want to set the texture. So we can go M, P, x-axis params, right, dot, texture, equal to S, texture. Then I want to get the texture from the main registry. So auto, P, x-axis, texture, main registry, dot, get asset manager, dot, get texture, S, texture. Oh, exit texture. Another thing you guys probably caught. Change that. Let's go back to change all of these. Go back to the .h file and change it there as well. Okay, go back. So we're getting the texture. Now we want to assert. So Scion assert that P axis P X texture must MP X axis params sprite dot width is equal to P X axis texture get width, then get height in this case. And then the color is just going to be the axis color. So the default axis color is going to be the color of our sprite. Okay. Because these textures that I created are just white. So like the arrows and the other stuff, they're all white. So whatever color we set it to will be the color of that arrow. Okay. And then we're going to want to generate the UVs. So from there we can go Scion or generate UVs. That's going to be for this sprite. And we want the textures, width and texture height. All right. So we set up the x-axis. Now we want to set up the y-axis. So we want to check to see if not MB only one axis. Copy all this. Change everything for the y-axis. Awesome. All right. I don't think I missed anything. We'll find out shortly if I did. And off the hop, I want to hide everything. Cool. All right. Hopefully that makes sense. Now we'll do the examine mouse position last. It's a bit more involved. For now, we'll do the get delta. First thing I want to do is check to see if I am over the tile map window or out of bounds. Because remember, a gizmo is just a tool. So I can just say if not is over tile map window or out of bounds. We're just going to return 0.f. Then I want to say if not MB over x-axis and not MB holding y. So if that's true, we just want to return 0.f. So now we want to check to see if our mouse button is pressed. So we go if mouse button is pressed, and we'll say abstract tool mouse button left, and your mouse is moving. MB holding X is equal to true. So if we're over the X-axis here, that means we're already over it. And then we're just press the mouse, like the mouse is pressed, that means that we're holding it. Okay. I want to return std ceiling of get mouse screen chords dot x minus m last mouse pause dot x. And we need to divide this by the camera scale. And we get access to the camera from the abstract tool. Cool. And we also need to check to see if the button has been released. And if it's been released, we want to turn off the holding. We go if mouse button just released. Abstract tool, the mouse button left. MB holding X is equal to false. And if it makes it to here, we just want to return 0.f. Awesome. And we want to do the same thing for the Y. Let's copy this. And just make some changes here. This one I'm also going to say or MB only one axis. So if it's only one axis as well, we just want to return 0. Shouldn't be using Y if we're only using one axis. I'm going to default to using X. Okay. That can stay the same, except we got to swap Y, not holding X. Oh, wait, not holding Y. These should both be Y. If not over Y, not holding Y, return 0. Yeah. This to X. This should be X. Or this should be Y, sorry. Y. This to Y. Y. Holding Y. Awesome. I think that's all we need. I believe it's set correctly. And let's do the set gizmo position. So I'm going to want to set the gizmo based on the center of the entity that we currently have selected. First, we're going to check to see if there's a sprite. If there's no sprite, then we will just center based on the widgets themselves or the gizmos themselves. So first, let's go float sprite width. We'll just have that as 0.f and height. Then I want to check to see if the passed in entity, the selected entity, has the sprite component. So if selected entity dot has component, sprite component. If it does, I want to get the sprite component and set our sprite width and height. Okay, so const auto reference sprite is equal to selected entity dot get component sprite component. Now there's another way you can do this as well. We don't have to do this has component check. You can just do the try get. I believe we already have a try get. Let's go back to this here. Has get place. It doesn't look like we did a try get, but there is a try get. Try get will return a pointer, but it can return null if it doesn't have it. Let's add that anyway. Let's copy this. Change this to a pointer. And we'll call this try get component. This would be, so we get the registry, and then this would return try get component. That would return a pointer. Okay. Now, this is not necessary. Like, we don't have to add this. Now, we do have to take this here and go back to .h file right here and add this in here as well. So we have the get component, try get component. Now we have those. Let's go back to our gizmo.cpp. This should build right now. Let's just build it just to make sure that adding that to the entity doesn't cause an issue. Okay, so that looks like it broke. Oh, you guys probably caught that. Build again. Awesome. So that build succeeded. So we added that in, the try get, which will return a pointer. This can be used instead of having to use the has. So you don't have to check to see if it has one. You just get a pointer and check to see if the pointer is valid. So it'd be one call, right? So instead of doing this call and then this call, we can just go try get. This can be a pointer. We can take this, put this in here, right? Get rid of that. And then if it comes in here, it'll be valid. We can go sprite width equal to sprite width. We can do the same with height. Just a little thing that'll have less calls. So this should be better. One extra call shouldn't have hurt anyway for this because we're not calling this every single frame. This is only called when we need to set the gizmo position. So now that we have the sprite height and sprite width set, we're going to want to go and get the transform. Now, all entities should have the transform. They all have them by default. Const auto reference transform is equal to, let's say selected transform. Selected, that's equal to selected entity dot get transform. Cool. Then we can go if not MB only one axis else. Okay. Now this is where we set the actual position of the axes for our params. Okay. So we're gonna want to go MP x-axis params transform position. Now we should probably be checking to see if these are valid as well, but I'm going to leave it for now. That's equal to the selected transform dot position, not rotation, dot position, plus the any offset that we wanted. So M axis params dot axis offset plus we're going to have GLM vec2. Put this down on the next line for now. And we're going to need to do the sprite width times the selected transform.scale.x times 0.5f. Why do we want to do that? Because we want to go to the center of the sprite. So we take the sprite width times its scale and then cut it in half. Okay. Now for this one, for x, I don't want to do the offset. But for the y, I do want an offset. So I don't want to do an offset of the gizmo texture. So we can copy this down, get rid of that, change this to the height, scale.y, half, and we want to minus the height of the x-axis param sprite because it wants to. We need it to be down further. Okay, we'll put this in brackets as well. MP x-axis params sprite dot height times MP x-axis params transform dot scale dot y. And all right. So there's the x-axis. So this one, we don't want to move it over in the x, but we do want to move it in the y. We need to move it down by the height. Okay. And we can copy this and we'll do the y. Now we only do it this way if we don't have one axis. If we have two axes, these are just values that I messed around with. Feel free to adjust these to where you want them to be. Cool. And y, change everything. Y. This change. Key stays scale. This stays width. But now we need to do this. This needs a minus as well. But not height. We want to do it for x and width. All right. We got to finish this. These all need to change to y. 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 I think I got it all. Let me know in the comments below if I missed anything. Well, when we actually start making the concrete classes, you'll find out right away if you missed something. Okay, and for if we have only one axis, we need to just make the one axis, okay, or set the one axis position. And it would probably be easier just to do it with the y and change everything to x. Copy this here, change this to x. Because this one, we actually do want that offset. X, that should copy. Right way, scale. Awesome. Control KD. That's it. That's it for setting the position. We can make this a bit smaller so you can see it all. All you're doing is setting it based on the selected entity. You want to center it and adjust accordingly. Adjust the position of the axes where you need them to be. Okay. So we're almost done. Let's go back up to the examine. All right. Actually, before we do that, I forgot something here. In the update function, we have to update the last mouse position equal to get mouse screen cord. Make sure that we do that because that's necessary. Okay. And back to the examine. All right. So examine, the first thing I want to do is get the current mouse world chords. So const auto reference mouse pos is equal to get mouse world chords. Now we want to check to see if we are hovering X Gizmo. X-axis of the gizmo. There we go. Const auto ref x-axis transform is equal to MP x-axis params transform. Now you don't have to do this. It looks a bit cleaner than this. I mean, we can do the same for sprite. But this can't be const because we'll be changing the color of the sprite. if we are hovering, right? Right. Cool. So then we go if mouse pause dot x is greater equal to x-axis transform dot position dot x and mouse dot x, get rid of this if, is less than or equal to x-axis position dot x plus x-axis right dot width times x this right or x-axis transform dot scale dot x. Copy this. Now we have to handle y. 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 Copy this. Doesn't need the end date here. Change all these to y. Height. Y and y. Awesome. So hopefully this makes sense. If we are greater than the position dot x of the x transform and less than the x plus the width scale, and for the y, for the height as well, okay, then we are hovering. So x axis right dot color is equal to MP this axis hovered color. And we can now set our MB over axis. Else, if we're holding it, we want to stay that color as well. Holding X. Copy this. We are also over X. Else, if we're holding Y, if we're holding Y, I'm going to want to set it to the disabled color. And then else, we just want to set back to the regular axis color. Paste that in. It's just the axis color. Awesome. All right. If we only have one axis or axis, we just want to leave. Turn. Otherwise, we need to do all this for the Y. We just copy this, paste, and start making all the changes. All right, I think that's everything. So let's just compile this. Oh, no, it is not. I'm glad that we found this. So we actually have to come up here. This is the last thing we were going to do for today. And we're going to do our default values for the gizmo. So if we don't pass any of this in, it'll just default to these values. So let's do that now. So the default is we're going to call a gizmo and fill this in. This is going to call this constructor. Okay. So we have our gizmo axis params. We can just do this. We can go dot transform. Okay, let me do that maybe. Is equal to transform dot scale is equal to CLM vector 2 1.f 5F. Now, these are some values that I had to come up with based on my sprites, like the textures that I added, not the sprites, the textures that I added in memory there. So we can go Gizmo, axis, frames. So there's a transform. And we're going to want to do the axis color. So axis color, and this one is just going to default to X axis Gizmo color. And then the axis hover color. X this. Then the disabled color. Oh, this is just grayed out. Grayed out Gizmo. See? Cool. So we got one, and we can put a comma here and copy all of this. Paste that in. Change this. It's going to be the opposite. And change these to Y, because this is the Y axis we're doing right now. Y, grayed out color. And this one also has the Y has an axis offset. Now we will tinker around with this offset. Let me just say axis offset. Also have to put is equal to GLM vec2, and it's just going to be negative. Control KD, and we have one more thing to do, and we need to set the one axis to false. By default, we have two axes, and that should handle it. All right, guys, that's it for this video. We're going to build, and after the build, that's going to be it. Let's just see if it builds. Awesome. Build successful. Let's run it. Should run fine. Cool. Now, it doesn't do anything right now because we just created the abstract classes for the gizmos. But in the next video, we will handle making the translate, and we'll try to do all three if we can, depending on how fast it is. If not, we'll just do one at a time. If you want, as a challenge, go ahead and try to see if you can figure out how to make these gizmos yourself as a little challenge. And all you have to do is basically create a concrete class and use the textures and everything accordingly and see what you can figure out. All right, that's it for this video. Make sure that you like and subscribe, and take it easy.